Hi everyone. Today we'll be discussing about ensemble models and what ensemble models are. Uh, it is combining, like we saw for linear regression, random forest, we have different linear regression, logistic regression, and say decision tree, we have different models, right? What ensemble models does is it will combine uh, different models and gives out a better performing model. What it means is, how it works is, uh, sorry, uh, before even going to how it works, there are four types of ensemble models. There are four types, namely, first one is bagging, next is boosting, third is stacking, and the fourth one is cascading. These are different ensembling techniques. Now, uh, let's look at what is bagging. Bagging is a bootstrap aggregation technique. What it means is, consider we have a data set DN, and we will be taking samples from this data set, and we'll form a data set D1, similarly data set D2, D3, so on till DN, sorry, say DK. So we will essentially uh, taking samples with replacement using this bootstrap samples with replacement technique, and we'll get different samples. So for this each sample we will build a model. Say for D1 we'll build a model M1, for D2 model M2, D3 M3, so on till MK. So we'll have K models. Okay. And say if we are doing a classification algorithm, like if you're doing a classification problem statement, then for these models, like we have K models, right? From these K models, we'll do a majority vote. Like if a new data point XQ comes, so for this XQ, it will go to model M1 and it will give you an predicted, some value will be predicted YQ, YQ1, and here YQ2, here YQ3, so on YQK. So there'll be K predictions done. So from these K predictions, if you're doing a classification technique algorithm, then it will do a majority vote and it will give you a finally a YQ for this point XQ. If you are doing a regression technique, then we'll be using a mean or a median for the outputs of the K models. So this is bagging, means we are using bootstrapping technique to get sample data from our original data set, and we are aggregating these models by using a majority vote or mean or median to find the predicted value. Okay. And sorry, now coming to random forest. Random forest is one of a bagging technique. random forest. This one is a bagging technique. So how random forest works is we'll be having a base model, and then for this base model we'll be doing a row sampling for the data that we sent it to the base model, right? We'll be using a row sampling and then feature sampling. We'll be doing both the things. So for random forest, the base model is decision tree. And this row sampling plus feature sampling will be part of bagging technique. So what happens is, say for the random forest model, we have a data set, say DN, and if this data set has n rows and d columns, d features, you can say. So, excuse me. So by doing row sampling and feature sampling, for we'll be getting a sample data set D1, similarly D2, so on till dk. And for D1, there could be D dash dimensions, okay, and samples could be M samples. So M samples and D1 dash dimensions. Similarly, this could have M2 samples and D2 dash dimensions. Like what I mean is here the dimensions for D1 can be different from dimensions from D2 because it is doing a sample for the features as well, right? So after all the for all these samples, we will build our models. Okay, so on till MK. Now for this, we will be applying a majority vote or a mean or median technique to give our final predictor variable YQ. And say we have for the original data set there are uh, n data points, right? And say for D1 we have m data points. So from the original data set there'll be remaining n minus 1 uh, data points from original data set, right? This can be used as our cross-validation data set for each of these models. So for D2, we have M2 data points. So for D2, the cross-validation data set will be CV for D2 will be N minus M2. So we'll be applying cross-validation techniques for each of these models, and we will come up with a like a proper number of base models here. Like we can go on building hundreds and thousands of models, right, for each sample, but we should do it in a much more efficient way. So to do that, we'll be applying a cross-validation technique, and we'll be coming up with how many number of base models are correct. So this is how random forest algorithm works.